Hello everyone, my name is patient Sarah, and we are dealing with a product that deals with detecting the risk of preeclampsia, and my teammates are Halai Patience Rita and Ojok Victory Esther. So we realize that preeclampsia is one of the leading causes of maternal deaths in Uganda, especially in rural areas where its detection becomes very difficult. And our stakeholders are the pregnant women, the community health workers that will be using our product. Realize that in traditional systems, they require the person to go there like physically to get the testing of the vital signs. And through that, we cannot be able to develop, like to realize the patterns in the data that has been given. However, with the use of AI and our product, the model can be able to see the complex patterns in the data, to be able to classify whether the pregnant lady, is at a high or low risk of getting preeclampsia. And through this, we can be able to reduce the maternal deaths that are caused by preeclampsia. So as we already talked about, our primary users include the pregnant women, the community health workers, and our secondary stakeholders include the Ministry of Health and other organizations that may be interested in maternal health. And through this, we can be able to see how our product is going to be used in the system. How is it going to function? We have the data providers. These provide the anonymized data that is going to be used by the developers in order to develop the predictive models that are going to state whether the person is at a high or low risk of preeclampsia. And after them developing this product, there will be the validators. They are going to see, is this thing working well? Remember, we are dealing with the medical sector, which is very risky, and the validators have to be there to see, is this thing really helpful or it's just causing more harm? And then we have the platform maintainers. That's the infrastructure, where our product is going to be based. And as we look at this diagram, it's explaining totally the ecosystem where we have the developers, the data providers, the validators, and the primary users. So we got our data set, and it had tabular data made, for example, the diastolic and systolic pressure, the age, the gravidity, and other maternal indicators that were helpful. Then it was anonymized, which was very good. This is our pipeline. When we got the data, it had to be cleaned. We had to handle the missing values. Then we had to select which features are very important for predicting the risk of preeclampsia. And when we're working on these things, since it was anonymized, it was following the Data Protection and Privacy Act, since the data could not be used to trace back to the original person. And through the use of this data, we're able to train our model to give the prediction of preeclampsia. So our system basically deals with a graph neural ensemble that combines GAT and RGCN. Remember, GAT mainly deals with attention weights, and RGCN deals with relationships. So through this, we're able to combine and build a better thing. And our inputs were tabular, as we had talked about earlier, systolic, protein, gravity, and other health indicators. And through the use of these two models, GAT and RGCN, their ensemble, basically, we were able to classify the low or high risk of preeclampsia. And basically, this is our architecture, where we had the input, then the graph construction with the patients as our nodes, then the relationships as the edges to see the relationships, and how we're going to use this to be able to classify the high or low risk of preeclampsia. So we use the different matrices to see how our system works. These are the technical matrices. And when we're using our system, realize that it was giving feedback in real time, which is very important and in the medical sector. Then as we're building our system, we hope that if we get 85% satisfaction among its users, then our system will really work very well. And through this, we hope that this will achieve a 30% reduction in the late preeclampsia detection, which will be very helpful in reducing the maternal deaths. So this table just basically shows the evaluation matrices that we used and why we chose the combination of gut and RGCN. You can see that recall really performed better for RGCN, and XGB was basically the model, like the starter to see how our data set is. It was basically the starter to see how the data set was performing. And then we used RGCN and GAT to see more complex relationships. So one of the advantages we have is that our GAT and RGCN is really good for developing systems that can be easily be deployed, and the accuracy was quite good, and it was providing real-time feedback, which is very helpful because we need to know which, like, where is the pregnant woman standing, like is the pregnant woman at a high risk or low risk. And remember, medical things involve real-time feedback because we have to know there is a life in fact lives at risk, the baby and the mother. So through this we had a very good advantage since the combination was providing a real-time feedback. So after developing our system, we hope to make partnerships with hospitals and clinics to ease the distribution. And since it's also an HAI, it will be more easier. And then we realized, like, after deploying it, we'll need to make more improvements basing on the feedback that we shall have gotten from the users. Maybe there are some things that we missed as we're developing it. Then when we add those things there, our users will be very satisfied with the system, and we hope to use workshops to display how our product works, how useful it is, and to show that it can really be helpful in the prediction of preeclampsia. So we quite did a lot of work, and we are going to use different systems. For example, the freemium, where this basically, it does basic things like the mother can use it, or the community health workers, to get the prediction of either high or low risk of preeclampsia. However, we can have a better advanced one, which requires subscription payment, and this basically shows analytics and it tracks different things that the freemium may not be able to do, and through this we may be able to get some revenue. This basically shows the different resources that we used, and the human resources include the data scientists, then the engineers who are able to come up with this model, then the technical infrastructure. That's what we used after testing our model. After testing our model, this describes the entire deployment structure. Then the data infrastructure, this shows our data set structure, like where we got it. Then we hope for financial resources, which will be very helpful to work hand in hand in different things, as we are going to see. Yeah. So this basically shows our different activities, the model life cycle. These are basically the things that we did. We got our data set, we cleaned it, we engineered it, then we did the different models, XGB, GAT, RGCN, then the ensemble, then the deployment, how we deployed it to easily be accessed by our users. Then we intend to give continuous monitoring of the model, like to improve more features in order to make it more user-friendly and also make it more efficient in use. Then we hope to get continuous feedback from our users in order to improve on the working system. So our partners, we hope to, our partners, for example, we already used the render, which was the cloud hosting, basically, which helped in the back end of our system. And we hope to maybe get investors who will be interested in our system in order to fund it and to push it to the intended users who really need it. So through that, this basically shows how we intend, in case we get an interested investor. Remember, data, our thing keeps on increasing, and currently we use the small data set. So if we intend to to get a bigger data set, we will have to do some funding, then also to expand our deployment structure. Also, we intend to get more people on the team, to include medical personnel to monitor us, because we are not well versant with what we are really doing on the medical bit. So it will be really helpful, and also to help us in our outreach to expand the use of our product. Then we intend to get feedback, as we already talked about, to be able to ensure that our system works well, and we see what things that major things that we missed about. Then we intend to write a report about how the different things that we passed through in developing our model, including the limitations, which are very important, because when you're using something, we need to know what really can't it do, which will be very helpful in the medical sector. So we intend to expand our system, and through expanding it, we have to have measures on how. Remember, if a system was basically built to accommodate a few things, when you expand it, you have to improvise measures so that it doesn't break down. So we have to improve our deployment structure to be able to accommodate the different features. Then we also, since it's supposed to be a local, to be used by also like the local people, where with limited resources, we intend to include more languages apart, because it basically now uses English. So if we can include other languages depending on the region, Luganda for Central, and Kole, it will be helpful since it is in a language that they understand. Then we also have to keep on retraining that thing to ensure that it's adapting to the different features. So this basically shows how we are going to handle. Since we already talked about our report, we have to script all this, starting from the AI model innovation, how we started, what we considered to choose the assembled thing, what we chose to be as the input features, and also the deployment structure. So if we're able to use this and script them, this will show our intellectual, and also maybe if we can get a license for it, it will be very helpful. So this basically shows that team contributions. I worked with these people. In case of any queries, any questions, feel free to contact us. Thank you.